We're really stepping into trig now. We are talking about the unit circle. Do not let the unit circle scare you. It is just a circle. The difference is we're going to use radians. We do already know that x squared plus y squared is equal to 1. And the reason it's called a unit circle is because all of our radii are 1. So the radii around this whole circle is 1. This is why we have these points. Over here, we have 0.10, which makes sense because if I looked at this as an x-axis and a y-axis, the point right here would be 1, 0. The point up here is 0, 1. So it's written just like xy. The point over here is negative 1, 0. And the point down here is 0, negative 1. We are working in lesson 4.2. We're doing trig functions. And our essential question is, can you identify a unit circle and describe its relationship to real numbers? I know the circumference all the way around a circle is 2 pi. We are going to be working with some new words. You guys have worked with sine, cosine, and tangent. And now we're going to work with cosecant, secant, and cotangent. So let's look at what all of those are. The sign of a number, t, is y. So the sign, we're typically going to look in the y. So we're looking at a point, xy. We're going to look at the y. Cosine is going to be the x. And the tangent is going to be y over x, where we know x cannot equal 0, because anytime we have 0 in the denominator, it makes it undefined. Going across from the sign, the cosecant is the flip, 1 over y. The secant is the flip, 1 over x. And the cotangent is the flip, x over y. You will have this memorized and know this like the back of your hand as we work with trigonometry. So the whole unit circle has everything to do with a radius of 1. So notice this is a radius of 1. And it also has everything to do with our right triangles. So notice if this is a radius of 1, we have to remember what right triangles tell us. 30, 60, 90. Across from the 30 is x. Across from the 60 is x root 3. And across from the 90 is 2x. So we have to go back to our special right triangle that we're making here. And let's see what's happening. So I'm going to draw in that this is a 30. Okay, this is the 90. So remember that this 1 is 2x. If that 1 is 2x, that would make this right here across from the 30 1/2. And notice right here on the y, I have 1/2. Across from the 60 is going to give us this right here, the x point. So notice I'm going back and forth on the x-axis, and that x point is going to have to be root 3 over 2. So let's go back and relate it. Remember that this is x, remember that this is 2x, and remember that this is x root 3. And that's what our special right triangles tell us. So whether you memorize it, which I don't ever encourage anyone to memorize the unit circle, or if you watch a video on my Canvas, I have a video called the left-hand trick, or if you're online, you could just Google the left-hand trick, and this woman, Miss Pruitt Britton, teaches it, and I really like it. But that is how I would do a 30, 60, 90. Now I'm going to look at the other 30, 60, 90, which is here. I don't have it drawn out. The reason why this is a 30, 60, 90 is because this is going to drop here, and this is going to be 60, this is going to be 90, and this is going to be 30. So notice what changes now. I'm going to try to get different colors. What changes now is my 1/2 is the small side. So before it was over here, now it's over here, so the 1/2 is now the x. And the 1 is here, so the root 3 over 2 will be my y. So those are the 30, 60, 90s. So this is root 3 over 2. The only other thing we didn't look at is a 45, 45, 90. 45, 45, all the 45 degrees are really user-friendly because notice that these are at x, x, and x root 2. So no matter where I am at a 45 degree, let's go ahead and go back to our unit circle. I'm going to change this color. Let's see if I have another color up here. I have a hot pink. Here is my 1. This is my radius in hot pink. And I'm dropping it right here. So remember, if this is 1, it's x, x, x root 2. Well, 1 is equal to x root 2. When I divide each side by root 2, I get x equals 1 over root 2, but I have to rationalize the denominator. And that's where I get, sorry, I multiplied it by root 2 over root 2. That's where I get root 2 over 2. So notice here and here, they're both going to be the same. So this x will be root 2 over 2, and this y will be root 2 over 2. The only other thing that I didn't discuss were these non-angle angles. That's what I call them. So notice if I have all of my points at 90, 180, 0, these are those numbers that I went over in the beginning. This is 1, 0, this is 0, 1. Now, the reason why we only have to memorize the first half is because we're going to look at a couple things. Location, location, location. So I know if I'm looking at the unit circle, here I have location, location, location. This will be positive, positive. When I'm over here, we have negative, positive. Because remember, we're talking about the x-axis and the y-axis, and we're talking about a circle inside of there. When I go down to the third quadrant, I have negative, negative. So first quadrant, second quadrant, third quadrant. And our fourth quadrant is going to be positive, negative. So the first thing you want to look at is location, 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 and then see whether it's a 30, 45, or 60 degree angle. Our non-angle angles will be at all the points that actually touch my 0, 90, 180, 270, 360. So we're going to look at one question. It says evaluate the trig function at each real number. First thing, some of you don't even know where 2 pi over 3 is. So let's first, if you have to, let's convert that to degrees, because most of you could probably figure out in degrees. Pi's cancel out. 3 goes into 180. How many times? 60 times, and 2 times 60 is 120 degrees. Well, if I was to look at a unit circle, remember we're traveling around 120 degrees. This is called the reference angle. So I know that I'm going to draw my unit or my radius of 1 right here at 120 degrees. But what I really need to look at is when I drop this and make a right triangle. Okay, so this is my angle 120 degrees, but the real angle that I need is called 60 degrees because that's going to give me my 180 degrees. So I know that I looked up here and my 60 degrees was this right here. 1/2 at the x and root 3 over 2 at the y. I also need to know which one is sine, which is cosine. And we learned that back in our notes. Remember, sine was the y, cosine is the x. So I'm going to just go ahead and state, guess what? These go in alphabetical order. Love that. This is cosine. This is sine. So let's go back to our question. I know sine is root 3 over 2, and cosine is 1/2. I'll go ahead and show all this so you can see. So sine was root 3 over 2. Oh, wait. Location, location, location. That brought us to quadrant 2. So I know that at cosine sine, one of them had to be negative. The cosine had to be negative. Then my tangent is just going to be root 3 over 2 over negative 1/2. Well, remember when I divide, I'm just multiplying by the reciprocal. These cancel out very nicely. And for tangent, I get negative root 3. Now, I have to flip everything, but this is not user-friendly for me, so we'll just deal with it. The flip of my sine is going to be my cosecant, 2 over root 3. Yes, I have to rationalize. You will get so used to rationalizing in your head that you'll just know how to write it. But as for now, I'm going to show my rationalization. The flip of cosine is sec. Well, that's fun, negative 2. The flip of tan is the cotan, negative 1 over root 3. Yes, I have to rationalize. And my answer is negative root 3 over 3. Now, typically, I like it to be in sine, cosine, tan, cosec, sec, cotan order, and that's probably how most of them will be set up.